Okay. So homomorphism, isomorphism, and related theorem. So what is homomorphism? And then when the homomorphism will be isomorphism, we will discuss. Okay. So let's define this homomorphism first. I'm just taking this red ink. So this is what is the homomorphism actually? So if a function is here f from g to g dash. Okay. Here g is just group with the star operation. Okay, and I'm taking this g dash with this is o operation. Okay, like this. So you can remember that o is the binary operation in g dash and this star is the binary operation in g. Okay, so if there is a function from g to g dash, ठीक है, in such a way that if you have we have just look at here, this is actually your g and this is actually your g dash. Okay, and here if we have two elements a and b in this. Okay, so clearly if you are operating together a and b, this will be also belonging to g. Okay or not?
Yes, sir.
Okay, this element
Eh,
जी का ही मेंबर होगा। और इसके लिए अब ऑब्वियस सी बात है, अगर हम कोई फंक्शन जी से जी डैश के ऊपर अप्लाई कर रहे हैं, इट मींस फॉर एवरी एलिमेंट वी हैव इमेज इन जी डैश, है ना। तो ये जो ए स्टार बी है, एक अनदर एलिमेंट आएगा दैट इज अदर देन ए एंड बी। सो इसको अगर ऑपरेट करेंगे तो यू विल हैव सम एलिमेंट लाइक दिस। ओके।
yes, sir.
ओके, तो ये एक एलिमेंट है। अब ऑब्वियस सी बात है, ए है तो ए की भी इमेज यहाँ पर कहीं ना कहीं होंगी, एफ ए सपोज दैट। और बी की भी इमेज यहाँ पर कहीं होगी, दैट इज योर एफ बी। क्लियरली दिस इज एफ इज सम मैपिंग सम फंक्शन फ्रॉम जी टू डी जेड। इसमें मैचिंग मीन्स, मैपिंग का मतलब है
Yes,
कि
sir.
दैट फंक्शन इज वेल डिफाइंड, है ना। फॉर एवरी
Yes, sir.
एलिमेंट ऑफ जी वी हैव अ यूनिक एलिमेंट इन जी डैश। ओके, so what is
Yes, sir.
which type of function is said to be homomorphism? If you have a and b in this, any a and b, and you are operating together, you will get an element a star b. And if you are applying this f on this a star b, you will get this element. Okay. Okay, and also on A you have FA and on B you have FB। तो अब ऑब्वियस सी बात है, ये G डैश के अंदर ऑपरेशन क्या है, O है। तो इसका मतलब है G डैश के जो ऑपरेशन एलिमेंट्स होंगे उनके बीच जो ऑपरेशन होगा वो O डैश का लगेगा। इसका मतलब है एक एलिमेंट FA हो गया G डैश का, एक एलिमेंट FB हो गया G डैश का, और इन दोनों को आपस में ऑपरेट करा तो कोई ना कोई एलिमेंट मिलेगा, है कि नहीं।
Yes, sir.
वो एलिमेंट इसी एलिमेंट के बराबर होना चाहिए। समझ गए ना। कहने मतलब है कि ए और बी यहाँ पर
Yes,
दो
sir.
एलिमेंट हैं, इनको आपस में ऑपरेट करा, ऑपरेट करने के बाद एक थर्ड एलिमेंट मिला, उस एलिमेंट की जो इमेज है वो वही होनी चाहिए जो हम एफ ए और एफ बी को आपस में ऑपरेट करने के बाद पाते हैं। ठीक।
Yes, sir.
तो
Yes,
इस
sir.
तरीके की जो मैपिंग होगी उसको हम होमोमॉर्फिज्म कहते हैं। दैट मैपिंग इज कॉल्ड होमोमॉर्फिज्म। इट इज नॉट नेसेसरी दैट ऑल मैपिंग्स हैव प्रिजर्व्ड दिस कंडीशन। ठीक है, इफ अ
Yes, sir.
मैपिंग इज
Mm.
प्रिजर्विंग दिस कंडीशन, दैट मैपिंग इज सेड टू बी होमोमॉर्फिज्म। ओके।
Yes, sir.
Okay, so you easily say this said to be homomorphism if this is f a star b, and you understood f what is the star? Star is the operation in g, and here this is equals to fa and this is o in b, because this fa and fb are the element of g dash. Okay, then if you are operating together, the operation should be from g dash. Okay, and this is for all a and
Yes, sir.
b in g। got it? So if a function
Yes, sir.
इस टाइप, तो एक्चुअली जनरली लोग इसको रिप्रेजेंट कर देते हैं ऐसे ही, लाइक लुक्स लाइक दिस इज एफ ऑफ ए बी इज जस्ट इक्वल टू एफ ए इंटू एफ बी, इस तरीके से भी लिख देते हैं। बट आपको इंश्योर करना है यहाँ ए और बी जो पहला हमारा सेट है उसके बीच के ऑपरेशन है, इनके बीच में ऑपरेशन स्टार है और इनके बीच में ऑपरेशन ओ है। ठीक है।
Yes.
ओके। तो जो दूसरा सेट है, मतलब मान लो हमने जी से जी डैश के ऊपर करा, तो उनके बीच में ये चीज आपको ध्यान ऐसे जनरली लिख दिया जाता है, बट हियर इज ऑपरेशन डिफरेंट। दिस इज ऑपरेशन, बाइनरी ऑपरेशन फ्रॉम द सेकेंड सेट, एंड हियर द बाइनरी ऑपरेशन फ्रॉम द फर्स्ट सेट। क्लियर?
Yes,
क्लियर और
sir.
नॉट?
Yes, sir. Clear है.
ओके, सो
Yes, sir.
if you have this function f that is called homomorphism, if it's preserving this condition, ओके, सो अगर हम कंडीशन करते हैं तो यू नो दैट कि अगर एफ जी पे ऑपरेट होता है तो यू हैव सम एलिमेंट्स, सम रेंज, है ना? इस रेंज को हम बोलते हैं होमोमॉर्फिक इमेज। इफ फंक्शन इज होमोमॉर्फिज्म, देन दैट इज कॉल्ड होमोमॉर्फिक इमेज। गॉट इट ना?
Yes, sir.
ऑफ जी, and this symbolism is represented like this, looks like this is gz, it means g is homomorphic to gz. Okay, so this is about your homomorphism. So if you are want to check a function is homomorphism or not, you will have to check this condition. If this condition is true for all the ab, then that function will be homomorphism. If there exists at least one pair where this condition does not exist, so that function will never be homomorphism. Okay.
Yes, sir. Yes, sir.
So next, isomorphism. So isomorphism is basically this is a homomorphism and as well as one on two mapping. A function which is one on two as well as your homomorphism, isomorphism. So if this is called f from g to g dash, and similarly here the g star and tall, so this is homomorphism, one on two and one on two and plus homomorphism. So that type of function is called uh, isomorphism. Okay, got it? It means
Yes.
if the function is bijective and that also preserve this condition at satisfying this condition, that is of homomorphism, that type of function is called isomorphism. So
Yes, sir.
here this uh, be represent here, if G is isomorphic to G dash, to be simply write like this, is isomorphic to dz. And this is very important condition. If a group G is isomorphic to G dash, and one thing we know, if there the f which is from x to y, है ना, and it is bijective, it means one on two. ठीक है, इट मीन दैट cardinality of x is equal to cardinality of y. It is possible only when this cardinality of both the sets is same. It means that if I am just saying this is f is one and on two, it means that cardinality of g is just equal to cardinality of g dash. Okay, it means both the groups have the
Yes,
same
sir.
number of elements. Got it?
Yes, sir. Yes, sir.
And another thing is here, by the homomorphism we can able to say that the elements from the group G, what the property have, that also have the respective elements of the, if I'm just said this is A in G and you are mapping here F, and you will get it something element in G dash, so this FA have the same property as Fa. So this is, I will later we discuss about the some theorems and results. So it means that this is isomorphism of the two groups. One group is isomorphic to another. It means there exists an isomorphism between them. Okay. Or if there exists an isomorphism, then it means that both the groups look is, or you can say they are same group by the property of the studying the property of the group. Okay, like ये
Yes,
हमारे
sir.
पास जो आप periodic टेबल नहीं पढ़ते हो, periodic टेबल में ग्रुप होता है ना, कि इस ग्रुप के
Yes, sir.
सारे
Yes, sir.
एलिमेंट्स हैं, है ना। तो उस ग्रुप के जो एलिमेंट्स होते हैं उनकी प्रॉपर्टी सेम होती है। उसी तरीके से अगर
यस
दो
सर।
हमको ग्रुप्स मिल गए और उनके बीच में आइसोमॉर्फिज्म है, तो इसका मतलब एक ग्रुप जो प्रॉपर्टीज रखता है, उसके एलिमेंट्स जो प्रॉपर्टीज रखते हैं, एलिमेंट्स की प्रॉपर्टीज मीन्स कि उनका ऑर्डर कितना है ना, एलिमेंट्स का इन्वर्सेस क्या है, वो साइक्लिक है कि नहीं, है ना। अगर एक ग्रुप साइक्लिक है तो दूसरा भी साइक्लिक होगा। तो हम लोग करते
साइक्लिक
क्या
होगा
है
जी
कि
सर।
हम जो हमको हम यूजर फ्रेंडली कह सकते हो कि जो हमारे पास ऐसे ग्रुप्स, उनकी स्टडी करना बहुत सिंपल होता है ना, तो हम उनकी स्टडी
यस
कर
सर।
लेते हैं। बट और
यस
फिर
सर।
हम क्या करते हैं, उसको दूसरे ऐसे ग्रुप की स्टडी जिसकी हमारे पास स्टडी करना थोड़ा टफ है, उनके हर एक एलिमेंट्स को वेरीफाई करना इज टफ इनफ, तो हम क्या करते हैं, आइसोमॉर्फिज्म बिल्ड करते हैं। ओके। और आइसोमॉर्फिज्म बिल्ड
यस सर।
करते हैं तो हमको पता चल जाता है कि जो एक ग्रुप है जिसकी स्टडी हमें करना बड़ा डिफिकल्टी लग रहा है, उसकी प्रॉपर्टीज हमारे पास हैं, उनके एलिमेंट्स की प्रॉपर्टीज है, उसमें किस तरह के एलिमेंट्स हैं, कितने एलिमेंट कितनी ऑर्डर रखे हैं, ये सारी चीजें हमें पता चल जाता है। ठीक है। तो दिस इज द मेन
यस सर।
पर्पज ऑफ दिस, इज वेरी 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 इंपॉर्टेंट टॉपिक इन एस्पेक्ट ऑफ अलजेब्रा। ओके।
यस सर। यस सर।
तो to prove F is homomorphism F of the two group G and D, so one has to prove only one statement, F algebra operation, that is image of the product of the two elements, है ना। तो अगर होमोमॉर्फिज्म दिखाना है तो तुमको कंडीशन दिखानी है केवल, अगर आइसोमॉर्फिज्म दिखाना है तो वन वन ऑन टू भी दिखाना है। अच्छा, वन वन ऑन टू तो पता ही है। वन वन ऑन टू मीन्स if some two elements a1 is not equals to a2, then their images should not equals to, है ना, वो इक्वल नहीं होनी
यस सर।
चाहिए। या
यस
फिर
सर।
अगर हम कह रहे हैं कि दो इमेजेस इक्वल हैं, तो इसका मतलब है वो उनके एलिमेंट्स भी, इसका मतलब वो एलिमेंट सेम है, तभी उनकी इमेजेस सेम हो रही। दो डिफरेंट
यस सर।
एलिमेंट्स की इमेज सेम नहीं होनी चाहिए, देन अदरवाइज वो मैनी वन हो जाएगा। तो इफ दिस
यस
कंडीशन
सर।
भी है, दैट इज इम्प्लाइज ए वन इज इक्वल्स टू ए टू। इफ
वन
दिस
वन।
कंडीशन है, दिस इज इम्प्लाइज दिस कंडीशन, if a1 is not equals to a2, their images should not equals to। Okay.
यस सर।
And what
यस
meaning
सर।
of onto? Onto means that image of this G should be equal to G dash. It means range is just equal to codomain. This is the definition for onto. So how you can
यस
say?
सर।
It means for every element in G dash, there exists an element in G such that element in G dash is related to the element of the G. Okay. It means for all
यस सर।
y in G dash, we have x in G such that this y is related to this x. Got it?
यस सर।
So this is the sum one on two. So if you are going to check, you will have to check this thing, that image is totally is just equal to codomain or not, or is it is one or not. Okay. So let us, we have some theorem, that very important theorems. Let's study this. So one by one. तो टू डेफिनेशन यू हैव अंडरस्टूड, समझ में आ गया ना।
यस सर।
अच्छा, बताइए आइसोमॉर्फिज्म क्या होता है।
आइसोमॉर्फिज्म सर वन वन और एंड ऑन टू और होमोमॉर्फिज्म से मिलके बनेंगे।
हाँ, होमोमॉर्फिज्म की कंडीशन को भी सेटिस्फाई करे, है ना। और
यस सर। यस
होमोमॉर्फिज्म
सर।
का मतलब है कि वो हमको कंडीशन केवल दिखानी है कि एफ ऑफ ए बी जस्ट
यस
इक्वल
सर।
टू एफ ए इंटू।
टू एवरी।
सो लेट अस प्रूव वन थिंग, थ्योरम इज हियर। लेट अस टेक अनदर पेन। its name is theorem 1. So what is this they asking about? Prove that in a homomorphism, in a homomorphism or an isomorphism, it means if a function is isomorphic, it is also homomorphism. ठीक। तो if the function is isomorphism, that it is okay, we can prove this result। So if it's something
Homomorphism.
true for homomorphism, it will be also true for isomorphism. Because in
Yes, sir.
isomorphism, there are two properties is more. Okay.
Yes, sir.
Okay. So if something is true for homomorphism, it definitely true for isomorphism. So
Yes,
what
sir.
we have to prove that of two up two groups, the the identities, okay, and inverses corresponds. What meaning of this? It meaning of this, if there is a G and we have two G dash and its identity is E and its identity is E dash and F is some homomorphism, okay, then FE is mapping to E dash. Got it?
Yes, sir.
Got it or not? Okay. And what
Yes, sir.
meaning
Yes,
of
sir.
inverse corresponds? It means if there is a in G, okay, then how obviously baat hai, there exists inverse of A in G. So
Yes, sir.
uh, this inverse of A, okay, will be equal to FA inverse. It means that it is A mapping to FA, है ना? Okay, and inverse of this will be equal to FA whole inverse, and this is inverse A. So this will be mapping to this. This is meaning of it. Okay. So
Yes, sir.
this will have to prove that identity map to identity of this another group, and the inverse correspond to the inverse of the respective element. Okay.
Respect
So
inverse. Yes,
let's
sir.
prove
Yes,
it.
sir.
You can also write in another way. You can write, maybe they ask in your examination like this. Let F is from G to G dash be a homomorphism or an isomorphism. It means there is no need of one on two, because if something is true for homomorphism, so it means there only importance here homomorphism. Okay, it's no importance of one on two. So
Yes.
they can ask this is true for this and this will be true for this also of a group G into a group G dash with identities E and E dash. Okay, I'm just saying the identity of G is E and identity of G dash is E dash respectively. Then we have to show that this is E mapped to E dash, and another thing is what, inverse of A mapped to the FA whole inverse for all in G. Okay, so let's prove one by one. प्रूव करें कि कर लोगे, बताना पड़ेगा.
यस सर, थोड़ा सा आप कर रहे हैं, थोड़ा सा.
थोड़ा सा बताना पड़ेगा. ओके.
यस सर.
ओके, लेट्स प्रूव. So let's start with the first one. Okay, so we know that is A is belonging to G, so definitely you can write this A in this way. Okay, since E is the identity of G, so we can write like that or not.
यस सर. यस सर.
Okay, and then you just apply this F on A. Already you will have to mention let let f from G to G dash, because in this I have written earlier, so there's no need to write. Okay, but if you are solving the first problem, it means the first this one. Okay, so you will have to write. Okay, I'm taking this f is a homomorphic function. This is a homomorphism. Okay, and e is the identity element in G and at all. You can have to write all these. Okay, I already written, so I'm going to prove it. Okay, so if A is
Yes, sir.
belonging to G, then A can be written like this or not. You can write. Now apply F on
Yes,
A.
sir.
So you can apply, this is F on A. Okay, okay or not?
Yes, sir.
Okay, now you can easily see, because we know this is homomorphism, so you can break it out like this. Since f of AB is just equal to FA and FB. And we are clear about it that here operation in the right side is operation of the G dash. Okay? Okay or not?
Yes, sir.
And this FA is, FA is from G dash or not? FA is from G dash. So you can, this FA you can also write looks like this. E dash. You can write or
Yes,
not?
sir.
Right now?
Yes, sir. Yes, sir.
Here
Yes, sir.
left side also the elements of G dash, and on the right side there are also the elements of G dash. Now you know that in a group there the left cancellation holds.
Yes, sir. Left
Okay.
hand. Yes, sir. Yes, sir.
Here in a
Yes, sir.
group the
Now
left
I see.
cancellation hold, so you can cancel it out.
Holds. Yes, sir.
So this
Hmm.
implies E dash is just equal to Fe.
Fe.
Since
Yes, sir.
in a group left and right cancellation hold. Left cancellation holds. Okay. So due to that we can write it. So this implies what? This implies, and here E dash is the identity of, here E dash is the identity of G dash. Okay.
Yes, sir.
So it means what? It means the identity of G is mapping to the identity of G dash. So first thing we have proved. Proved or not?
Yes, sir. True.
पहला तो प्रूव हो गया, दूसरा
Yes.
सिमिलरली इसको भी प्रूव कर लेते हैं, ये भी बहुत इजी है. तो व्हाट वी विल डू, सो अगेन, because we have proved this, so we can also use in the proving of the second. Okay, this thing we can use. So this is A belonging to G, so this implies there is A inverse is also belonging to G. So from there you can easily see this is A inverse with A. Okay, and if you are multiplying A inverse and A, you will get identity of G or not.
Yes, sir. A inverse multiply identity. I guess, sir.
Okay, now you can simply apply F on this. This is okay.
Yes, sir.
ठीक है, because since this is A and A inverse is also element from G,
Yes, sir.
so now you can break it out. You can break it
Yes.
out. So this will be what? This is A inverse of FA, looks like this. And you know that this is FE mapped to E dash, that identity of G dash is just equal to what? This is FA into FA inverse. Okay. For we know that this is FE is
Yes.
mapped to E dash. Got it?
Yes, sir.
Now, if you are multiplying, you know that now. If there are two elements, if I'm just saying A and B, you are multiplying and you will get E. And if you multiplying in the A first and B, you are just commute and you multiplying, you will get identity. So you easily
Yes, sir.
say that is inverse of A is B and inverse of B is your A. ये तो
Yes,
बोलते
sir.
हैं, है ना? If you are
Yes, sir.
multiplying two elements,
Mm.
you get identity uh, irrespective order of multiplication. Then one element is said to be inverse of another element. So here we are, what we got here? We multiplying two elements, FA inverse. This is also element of G dash, and FA is also element of G dash, and here identity of G dash is E dash, and in the FA and FA inverse. So what meaning of it? Meaning of it is what? That FA, this is an element in G dash, inverse of this element,
Yes, sir.
inverse of this element. Okay, and how we
Yes, sir.
represent the
Yes, sir.
inverse? Looks like this now.
Yes, sir.
This
ठीक
is
है.
something element and you will have to represent this inverse, then you can have to write like
Yes,
this.
sir.
This is
Yes, sir.
symbolism to represent the inverse. Okay,
Yes, sir. Inverse.
so
Yes,
it
sir.
means this FA inverse, it means inverse of this element will be equal to what? This one,
If inverse.
है ना? Or we can say also this is FA, sorry, FA inverse. Okay, wait a second. If you are using this thing, okay, this is FA inverse. Okay, FA inverse ka whole inverse, you will get FA again. This element and inverse of this element, they represented like this. Okay, now,
Yes, sir.
and it will be equals
Yes,
to
sir. Yes, sir.
FA. You will get this element again. So we proved it. We proved the second result also, that that much this is f of A inverse is just equal to f inverse. It means inverse is also correspond to the respective elements inverse. Okay,
Yes, sir.
right? So
Yes,
this
sir.
this is, we have this second one. So I think you can also prove another thing, the theorem second. This is your home assignment. You just proved by self. If G, sorry, not G, if there is a F from G to G dash, okay, be a group homomorphism. Be a group homomorphism. Okay, then prove that, then prove that homomorphic, from that homomorphic image FG of G is a subgroup of G dash. Okay, so this is home assignment. Prove this. We will meet in tomorrow's lecture. Okay,
Yes, sir.
so today I just leave here and you do by self, है ना? खुद से करो, देखो करके. ओके.
Yes, sir. Yes, sir. Okay.
तो अभी समझ आ गया कि क्या क्या होता है हमारे पास होमोमॉर्फिज्म, आइसोमॉर्फिज्म क्या होता है, और कैसे हम प्रूफ्स को परस्यू करते हैं, है ना? ये सारी चीजें आपको
Yes, sir.
आइडिया आ गया होगा. ओके,
Yes, sir. Yes, sir.
चलिए ठीक है, तो आज के लिए इतना ही करते हैं. वी विल मीट इन द